Okay, boys. Good morning. Today we're going to be talking about factoring polynomials to solve quadratic equations. We already know what a polynomial is. We've talked about it. We know how to add them and subtract them and multiply them. We're going to learn how to divide them tomorrow. But we know what a polynomial is. It's a set of one or more terms. And when we're talking about quadratic polynomials, we're talking about polynomials that have a degree of 2. Okay, but we'll get into that in a second. Now, before we get into solving quadratic equations by factoring, I just want to go over what we already do know and what we know very well. We know that the linear functions are in the form, are in the form of y equals mx plus b. Okay, where y is the dependent variable, x is the independent variable, m is the slope. Remember, the slope is the rise of a run. Remember, you have the formula for slope is y2 minus y1 over x2 minus x1. And b is the y-intercept. Please remember that the y-intercept is the y value on the y-axis when x equals 0. Please notice here in red that the degree of the polynomial is 1. The degree of a linear function, a linear function or linear equation will be 1. That is the degree. That is how you know that it is linear. And linear functions will render straight lines, okay? Such as, I just put a few lines here, okay? Okay, these lines are all linear functions because they have a degree of 1. If you guys remember, the slope of this line here, that slope, remember, is undefined. I don't know if you guys remember that or not, but if you don't, this is a good little mini review to make sure that you guys know this for the midterm. Please, can anyone tell me the equation of that line since it's undefined and it's going through an x and only an x? No, it'd be an x equals 1, 2, 3, 4, 5, negative 6, guys. Please, I'm a little disappointed you guys don't remember that. For this graph up here, the slope here is 0. It's a horizontal line. It's going only to the y-axis, so the equation to this would be y equals 1, 2, 3, 4, 5, 6. Very good. So that's the equation. And then, of course, for this blue line, this is my y-intercept, okay? My slope would be, how do I get from here to here? It's not a perfect point, so it's going to be a little tough to do that. But it would be a negative slope, okay? And the black one would have a positive slope. Okay, just a couple little things just to be a refresher. Please remember that the solutions of a linear function are those ordered pairs which make the function or equation true. For example, gentlemen, this point right here on this equation, okay, 1, 2, 3, 4, 4, comma, negative 1, is a solution because it's on the line. And if I were to plug that into the equation of this line, it would make the equation true. Please remember, those are the solutions of a linear function. The solutions of the system of equations, which, remember, we can solve a system by graphing, substitution, elimination, and we can use the matrix method of solving systems as well. The solution of a system of equations are the ordered pairs which make all of the given functions in the system true. So in this case, I made a system on purpose. This point right here, that's the intersection point of the black line and the blue line. That would be the solution of the system, okay? Again, we don't know the equations right now, but we do know at that point, when plugged into both the blue line's equation and the black line's equation, would make both equations true. So far, are we pretty good on the little brief overview that I just did? Okay, hopefully that was just a little bit of a reminder, guys, that the midterm is coming, and we've learned a lot already in this class. So please don't forget to review. Please, I beg you. Bless you. Okay, now, not quadratic, that doesn't exist, but quadratic, yes, that does exist. Quadratic functions are in the form of, again, why are in two form? I don't know why I'm doing that. Sorry about that, guys. Quadratic functions are in the form of y equals ax squared plus bx plus c. Please don't stress. Please don't stress. I'm going to give you some background information. All of this, I promise, we will go into huge detail on how to graph a quadratic and solve them and all that good stuff, all the different angles about it. But I just want to give you a brief synopsis of what you're looking at, because sometimes when you do math and you don't really know why you're doing it, it doesn't stick. But if you know why you're doing it, sometimes you find a correlation, you go, oh, okay, because this is what I'm looking for. And it kind of puts it more together for you. So quadratic function is in the form of y equals ax squared plus bx plus c. Remember, this is no stranger to you. Didn't we learn how to factor trinomials in that form? Okay, so this is no stranger to you. So that's, you can breathe a sigh of relief. Oh, okay, it's not too crazy. Okay, where y is dependent, of course, x is independent, of course. A and b are coefficients, which we will investigate later. Okay, we will investigate it later, I promise. Don't worry about it, just know they're coefficients. A is the coefficient of x squared, b is the coefficient of x, and c is the y-intercept. And we already know the definition of y-intercept. It's the y value on the y-axis when x is equal to 0. Notice that the degree of the polynomial is a 2. All quadratic functions or quadratic equations will have a degree of 2. That's what makes them quadratic. The degree of the equation or the function is what determines the kind of graph you're going to get. It's what determines the shape of the graph. Okay? It determines what kind of function you have. Quadratic functions render a graph called parabolas. Please, you don't have to worry about graphing these yet. This is just so you can see what the heck we're doing. When you have a parabola, guys, this is why I'm doing this. Not to torture you, but to give a little bit of meaning to today's lesson. The points at which the parabola crosses the x-axis are the solutions of the quadratic function. In other words, the x-intercepts are the solutions of the quadratic functions. So when you set this equation, okay, this function here is y equals x squared plus x minus 3, okay? We are trying to find the x-intercepts. The x-intercepts are the x values on the x-axis when y equals 0. So what are we doing here? We're saying 0 equals x squared plus x minus 3. Did you see what I did there? What did I replace the y value with? A 0. Why did I do that? Because I want to solve for x when y is 0. I'm trying to find the x-intercepts. Does that make sense, guys? So when I do my calculations, in this case you could not factor it. In this case you had to either do what's called completing a square, we'll get there, or you use a quadratic formula, we'll get there. But regardless, why I put this here, see how it says x is approximately 1.3 and x is approximately negative 2.3? Those are the solutions. And that is what we're going to be solving for today. Okay? Here, we don't know the equation, but we do know the solutions to this quadratic equation are that x equals 4 and negative 6. Because whenever we're solving for a quadratic equation, we are solving for the x-intercepts. The x values on the x-axis when y equals 0. Do you guys see where we're going then today? What we're solving for? Because that's all I really wanted with this here. I don't want you to stress about why is it pointing up, why is it pointing down, what makes it wide, how do we graph it. I don't want you to worry about that. I just want you to understand that the reason why we learn how to factor is so that we can find solutions of quadratic functions. Do you guys see the point of today now? Promise, guys, because this is important. Okay, thank you. Now, sometimes we can find solutions of quadratic functions, okay, by factoring. and using what's called the zero product property. Check it out. The zero product property, okay, states that for any real numbers, a and b, if a times b equals 0, then a equals 0 or b equals 0. So for example, if x plus 3 times x plus 2 equals 0, then that means that your x plus 3 is your a value. That's a term which is being multiplied to x plus 2, which is your b value. If a times b equals 0, then a equals 0, so that's why I put x plus 3 equals 0. Or b equals 0. That's why I put x plus 2 equals 0. So now from here, guys, you know how to solve these Mickey Mouse equations. So my solutions in this case would be -3 and -2. That's what the zero product property states. Okay? When you have the product of a times b, and that equals 0, a will be set equal to 0, and b will be set equal to 0. So for example, what if I tell you, what are the solutions of the equation 4x plus 1 times x minus 2? They have already factored it out for you. They have already put it into zero product property for you. So in this case, it is Mickey Mouse. Well, I know that 4x plus 1 times x minus 2 equals 0. So that means I have a product of a times b, which equals 0. So I'm going to take 4x plus 1 and set that bad boy equal to 0. And I'm going to take x minus 2, set it equal to 0. So x will equal -1/4 or +2. Now, we're not going to get into the semantics of how I came up with the sketch I'm about to come up with. I know how to sketch this because I've been doing it for a long time. I just want to put a face to these solutions. Basically, all we found here is that we know that this graph is pointing up and it's going through 2 and -1/4. That's all we know. That's what we found out from here. I'm trying to really drive this home so you can understand the function of what we're doing today. Does this make sense so far, guys? Yes? Okay. Now, let's just practice a couple that they're already set up for us. Mickey Mouse time. Okay? What are the solutions of each equation? I'm going to do these a little bit in my head. I know you guys can hang with me. I know you can. Okay? I got to set x plus 1 equal to 0 and x minus 5 equal to 0. So in this case, my x-intercepts will be -1 and 5. See? I know you can do it. For number b, I got to set 2x plus 1 equal to 0 and x plus 14 equal to 0. So my solutions would be -1/2 and -14. Thank you, guys. Great. Letter C. The product is 7n minus 2 times 5n minus 4 equals 0. So that activates the zero product property. So therefore, my solutions would be that n equals 2/7 and 4/5. Very good, gentlemen. Very good. And last but not least, the product of 2x plus 3 times x minus 4 equals 0. So that activates the zero product property, stating that I can set both equal to 0. So 2x plus 3 must be set equal to 0, and x minus 4 must be set equal to 0. So x would equal -3/2, because you subtract the 3 first, not 2 over 3. Be careful. Thank you. Good mistake. And +4. We good? We good so far? Everyone got that down? Okay. Now let's get to the real life stuff. Okay? This is real life. This is what you're going to see on SATs or ACTs or my tests or quizzes. And they're quadratic functions. But they're not going to be factored out for you in real life. Okay? Sometimes they will, maybe here and there, but I doubt it. And this is where I told you today's pretty easy because this is all old stuff that we just finished testing on and you just finished doing very, very well on. So to go ahead and solve these, step one, factor. We know how to factor, and I'm not going to really go too slowly here. Hopefully you saw what I just did. What times what equals 15, but when added together is 8. 3 plus 5. Remember, we're setting it equal to 0. That activated our zero product property. Boom. X equals negative 3 and negative 5. Hold for 1 second. All right, guys. So again, I'm not trying to bore you. I just want you to know what it is that you're solving for. Basically, I know that it's going to be pointing up because it's positive, but again, we'll go over that later. But basically, you know that you have a parabola. That's something like this, where my solutions are x equals negative 3 and x equals negative 5. I won't do that again, guys. I just want to make sure that you really understand what it is that you're solving for. Because there's nothing worse than just doing math just because. Oh, what am I solving for? It doesn't matter. Just get x. That's horrible, in my opinion. Does everyone understand what they're doing here today? You promise? Okay, so now, no more of that. Let's just get to the meat and potatoes of this. So let's go ahead and factor. Come on, guys, tell me. What do I got? n minus 7, n plus 2 is perfect. Because negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. And my solutions will be, I got to set them both equal to 0, 7 and negative 2. Done. Those are the x-intercepts. Those are the solutions of this graph. Next, number 3. What do I got, my man? Okay, p plus 5, p minus 4. 5 times negative 4 is negative 20. 5 minus 4 is positive 1. It works out. So my solutions would be p equals negative 5 and 4. Number 4. 2x squared minus 15 plus 18. Can I factor out a GCF? No. So I'm going to go ahead and I'm going to personally do the Cuban method. 2x, 2 times 18 is 36. That's my new C. What times what is positive 36? But when added together, it's negative 15. Negative 12, negative 3. Can I artificial factor, which a lot of you guys forgot on the test? Yes, I can. X minus 6. Does this 2 go on the outside? Why does it not go on the outside? Because it's an imaginary or artificial factor. Very good. Now, we set that equal to 0. What are my solutions, boys? What are the x-intercepts? 6 and 3/2. Those are the points at which the parabola crosses the x-axis. Yes, sir. Okay, that's a great question, son. Okay, what if you have something like this, guys? This is what my boy Jimmy asked. Let's say I had x cubed plus, let's see, come on, 4x squared. Let's see, come on. Let's just make it an easy one. Plus 4x. In this case, great question, by the way, son. In this case, can I factor out a GCF? Yeah. What? X. Now I'm going to have x squared plus 4x plus 4. That's a perfect square. So that's x plus 2 times x plus 2, right? Now check it out, guys. This was all set equal to 0, right? The beauty of the zero product property, it's as many terms that are multiplied together to equal 0. Each one of those terms will be 0. This no longer will be a parabola, by the way. This will now be what's called a cubic, okay? And you're going to do the same, though. You're going to set x equal to 0 and x plus 2 equal to 0. In this case, it's redundant, but you would set all of them equal to 0. So your solutions would be x equals 0 and negative 2 in this case, because it was a perfect square. Does that make sense, Jimmy? So you have 2 solutions again, maybe 3 even, but that's a totally different function, but it's a great question. Does that make sense? Thank you. Okay, now, what are the solutions of these equations? All right, went a little tougher now. Let's see. Can I can I do anything with this in this format? First of all, no. What do I got to do first? That's right. You always got to put it in standard form. Great job, guys. So you're going to subtract 18 to both sides. So I'm going to have 4x squared minus 21x minus 18 equals 0. Can I take out a GCF? Okay, so we're going to have to go the hard way, okay? But this isn't that bad. Just use your brain, guys. It's a tough one, but not really. 4 times negative 18 is going to be negative 72. Now just think. Look at the numbers here. What times what is going to be negative 72, but when added together is negative 21? How about this? Using the divisibility test. What numbers go into 72? 3. Okay, 3 times what? What's 24 minus 3? There you go. So I got negative 24 and positive 3. Guys, you do know that if you add these digits together, 7 plus 2, that's 9. That's divisible by 3 and 9, correct? We knew it wasn't going to be 9 because 9 times 8, 9 plus 8 is never going to give you 21. But it was divisible by 3 as well. So 3 times 24 is 72. Negative 24 plus 3 is negative 21. Artificial factor of 4. And I got x minus 6 times 4x plus 3. So my solution is going to be 6 and negative 3/4. You with me? Chris, especially since you have a test tomorrow on factoring, is that the factoring flowing with you, my brother? Okay. Next, same thing. Can we do anything with this equation in this format? No, so I'm going to have to subtract 49 to both sides. Add 49 to both sides, sorry. Pay attention, Mr. Morrow. So that's 49. And then this reminds me of a perfect square. I don't know about you. That's a perfect square. What's the square root of that? That's a perfect square. What's the square root of that? What's 7 times x times 2? Boom. So this is an x plus 7 squared equals 0. Now, I don't want you to stress out about this. A lot of people stress out about this, okay? Doesn't x plus 7 squared just mean x plus 7 times x plus 7? So there's only going to be one solution here, isn't it? It's going to be x equals negative 7. Okay? Because it's not two solutions, it's the same solution doubled up. Just so you guys know, I'm not trying to bore you, this is what this graph would look like. It only hits one point, so it would be something like this, where it only hits at that one point at the negative 7. Does that make sense?
Yes, sir.
Everyone with me? How you doing, Eric? Good, my man. Does that make sense, my brothers? Okay, now, let's put this into your favorite format, which is that of word problem, of course. I know you guys are excited. If you could see the happy faces right now in my class, internet land, you would be astonished. Okay, I think it's pretty cool what I did there. I put a little real painting. It's pretty neat. I think it's, yeah, that's what I think. I think I'm a Picasso. I painted that. No, I'm kidding. You are constructing a frame for a rectangular photo shown, okay? You want the frame to be the same width all the way, I don't know what area round is, but I meant all the way around the total width, all the way around the total area of the frame. Thank you. And photo to be 315 square inches. Guys, chill. What should the outer dimensions of the frame be? Okay, basically, guys, you have this painting, okay? And this painting is 11 inches tall, or rather, whatever, 17 inches. Well, it doesn't matter. Actually, it just doesn't look right. So let me do this the right way. I can't do this halfway. You got to do it the right way or don't do it at all, right? That's it, man. That's what I'm talking about. Okay, so, sorry about that. So it's 17 inches tall, and it is 11 inches wide. I want to put a frame, though, that is the same width all the way around. So that's why I'm making a frame here that is X inches wide all the way around. Does that make sense so far? Okay, now, this is something that kills people on SATs. It's not going to kill you anymore. You know that the area of a rectangle equals length times width or base times height, correct, guys?
Yes.
Either way, right? Okay. What area do they want, my brothers? Okay. So doesn't 315 have to equal? What is the total height, including the frame? Oh, God. Guys, hold on, relax. Let's think about this logically. From the top all the way to the bottom, isn't it going to be X inches plus 17 inches plus another X inches, guys? So wouldn't it be 2X plus 17? Right? Times, what's the width going to be? The width goes from here to here. So 2x's plus 11. Very good. So 2x plus 11. Does that make sense so far, guys? Okay, now, can I use the zero product property here at this point? No, I can't. I'm out of luck here. So what I can do, though, is go ahead and solve this. So I'm going to have 315 equals, let's FOIL, okay? We know how to do this. 2x and 2x, it's going to be 4x squared plus 22x plus 34x plus, I think it's 189. 189. 187. Yeah, 187. You're absolutely right. Thank you. Thank you, gentlemen. You with me so far, guys? Okay, so now, standard form, I'm going to have 4x squared plus 56x, and then 187 minus 315 is minus 128 equals 0. Do you guys see what I just did there? We have plenty of time, so I don't need to rush. I want to make sure you got this. Everyone saw what I did there? Okay, now, let's make our lives easy. Can I factor anything out? I would say by 4, guys. Let's make our lives a lot easier. So there's going to be x squared plus 14x minus 32. No, I said if you were factoring out an x and it was x cubed, it would not be a parabola. In this particular case, my brother, you're just factoring out a 4. It does not change the state of the function. Thank you. That's a great question. Thank you very much. So now let's do this. This is 4, and I got x and x. Okay, what times what is negative 32? But when I add it together is 16. 14. Now positive 16 and negative 2. So now, pay attention, guys. You do have 3 factors, though. So x equals 4, 4 equals 0, which that doesn't make sense. X plus 16 equals 0, and x minus 2 equals 0. Okay? That doesn't make sense. That's garbage. Here, x equals negative 16. That's impossible. You can't have a negative 16 measurement. X equals 2. That's it. 2 inches. So now, what are the final measurements of the whole entire painting? Because they're asking for that. Think about it, guys. It's 2x plus 17, which is going to be 4 plus 17, which is 21 inches. Yes, sir. By 2x plus 11, very good, equals 4 plus 11, which is 15 inches. So this painting is a 21-inch by 15-inch after you have put in the frame, and the frame width that you have to buy is 2 inches. That's math in real life. Does that make sense, my brothers? Okay, whoever said somewhat, how can I help you? Please and thank you. No? Okay, well, I'm done. Think about your questions, and let me just start recording this. Thank you, guys. God bless.